Numerical differentiation often tackles worded problems. Check the first example here in numerical solutions to see problems. The first problem is a classroom example, where the function is already provided. F of x is the root of half of x cubed plus 2x. The other details provided is the first x value of 3.5 and h of 2. We are to determine f prime of the first x value, the second, and the third. Then, we are to estimate f of x before the initial x value of 3.5. In order to start with the approximation, generate the dataset. The variables involved are the time in hours and flexural strength in pascals. Time is always an independent variable, and the problem has the initial time as 3.5. With time interval of 2 hours per test, the second result was taken after 5.5 hours, then after 7.5 hours. To complete the table, fill out the flexural strengths by using the equation. Place 3.5 for x for the first result, which comes out as 11.63. The second is then plugging 5.5, which makes 20.12. Then the third y has 7.5 for x, which generates 29.52. The first requirement is the rate of change at x of 3.5. From the dataset, this is the initial value, which shows that we cannot use a central function. The next options are first, 2-point forward, and 3-point forward. Between these two functions, the one with more points involved will yield a more accurate result, so we use 3-point forward. The function for 3-point forward is negative f of xi plus 2 plus 4 times f of xi plus 1 minus 3 of f of xi, all upon 2h. After identifying the most appropriate function, the rest is simple algebra with direct substitution. F prime of 3.5 is then computed as negative of f of 7.5 plus 4 times of f of 5.5 minus 3 times of f of 3.5 all upon twice of the 2-hour interval. Plug the values from the dataset, which makes f prime of 3.5 as negative 29.52 plus 4 times of 20.12 less 3 times of 11.63 all over 4. The rate of change at x of 3.5 is then simplified as 4.0175 pascals per hour. Next is to determine the rate of change at point 2, where x is 5.5. This point is between two other points, which makes it possible for us to use central function. With only a few data points available, we can use 2-point central, the function being the difference of f of xi plus 1 and f of xi minus 1 all over 2h. These can be interpreted as f of 7.5 minus f of 3.5 all over twice of 2. Simplified, the function becomes a quarter of 29.52 minus 11.63. F prime of 5.5 is then 4.4725 pascals per hour. The third requirement is the rate of change when x is 7.5. This is the last point in the table, which means we cannot employ a central method and even forward methods. Although, we can use backward methods. They are 2-point backward and 3-point backward. In this situation, more points bring about more accurate result. So choose 3-point backward, and its function is thrice of f of xi minus 4 times of f of xi minus 1 plus f of xi minus 2 all over twice of h. Relating this to the dataset, f prime of 7.5 is equated to thrice of f of 7.5 minus 4 times of f of 5.5 plus f of 3.5 all over twice of 2. Placing values from the dataset, we get 3 times of 29.52 minus 4 times of 20.12 plus 11.63 all over twice of 2. This is simplified as 4.975 pascals per hour. The last requirement is somehow to extrapolate the flexural strength of the sample when x is 1.5. With limited data points and from the available first derivative functions, what can we use to complete the task? We can't use 4-point central for the situation, as we lack data points. So the next option is to explore 3-point functions. By using 3-point backward, we can look for f of 1.5 by using data from x of 3.5 and 5.5. But this means we should look for f prime of 5.5. Since 5.5 is surrounded by other values, we can use 2-point central, as this yields the most accurate result. F prime of 5.5 is solved earlier using 2-point central, and it turned out as 4.4725 pascals per hour. So the first part of the computation has already been solved. The function for 3-point backward is thrice of f of xi minus 4 times of xi minus 1 plus f of xi minus 2 all upon 2h. This is like thrice of f of 5.5 minus 4 times f of 3.5 plus f of 1.5 all over twice of 2. Plug values from the table to have 4.4725 as equated to 3 of 20.12 minus 4 times of 11.63 plus the unknown f of 1.5 all over 4. The flexural strength at 1.5 hours is then solved as 4.05 pascals.